help you with Math Strategies 8, our e-learning day for this Wednesday, March 22nd of 2023. A lot of threes, a lot of twos. All right, go ahead, pause your video if you want, and come on back after you've completed week 27, 28. Why? I have put at least one mistake on here, so pause your video, come back when you're ready to check. All right, folks, now that you're ready, go ahead and take a look. There is at least one mistake, if not more. So pause your video, check for mistakes, come on back, and I'll zoom in. All right, so here's a zoom in. Pause if you need and check. Pause, rewind if you need. Again, there is at least one mistake, if not more. Be ready to discuss those next class day. So we do have IXL, but that won't be a big priority for today. Just know, I know Friday's coming along. You should be through Division H and Rocket Math, growing 10 points, knowing what your growth scores are. At this point, what I'm going to do is I'm going to continue on with the lesson that we were learning in class. We've already gotten through a bunch of this. My goal is to get through at least half of it on this video. You can do the other half on your own. So between the math review and this page, you should finish the first page today. That's your e-learning assignment. All right, I'm going to do 1, 3, 5, and 7, and then you're going to do 2, 4, 6, and 8. Just a reminder what we talked about in class. Remember that a perimeter is actually a length. And if all you want to know is the distance from here to here, that is one dimension. So if you're using inches or feet or miles, whatever the case might be, that's all you will write. On the other hand, if you're talking an area does not just have one dimension, it has two. So you would use square miles or square centimeters or square inches. Last but not least, getting into the 7th and 8th grade stuff where you finally get into volume. That's where you think about stuffing a freezer full of ice cubes. It's got a length, it's got a width, it's got a height, it's got 3 dimensions. So how many cubic inches of ice would fit that freezer? How many cubic kilometers would it take to build that volcano, whatever the case might be? Now, you're welcome if you've already understood and have gone through numbers 1 and 3. Feel free to fast forward through the video. I'm going to talk about number 1 first, where we have a perimeter. Perimeter fence means the area or distance, all the way around it. So 1 and 2 and 3 and 4 and so on. Now, in order to find that distance all the way around, you need the length of each and every side, the first side being 3 3/10. The next side, well, this appears to be a square where all side lengths are congruent. So you can either add 3 3/10 4 times, or you could simply multiply 3 3/10 times 4. In any respect, you'll get 3, 6, 9, 12, 12.3, 12.6, 12.9, 13.2, 13 and 2/10. And again, folks, all we wanted to know, how many inches would it take to get all the way around this? So that's just inches. Now, what if we're looking for area? Many of you will be very tempted to simply write area is equal to length times width. And that's not wrong, but please notice that a square has a equivalent length and width, which is why many people simply say side to the second power or side squared. But I know many of you are just going to latch onto the length times width, which is fine, knowing that with a length of 3 and a width of 3, we're going to multiply 3 3/10 times another 3 3/10. And get 10 89/100. Yes, you may use your decimals calculator on this assignment. In this case, folks, please recall we are measuring now an area. So, yes, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have little parts that are actually going to give us 10 89/100 square units. All right, as I go into example 3, you're welcome to pause, rewind, listen to it again, but I want you to think about how are these similar, how are they different for example 3. Perimeter, still going to add up all the edges. Biggest mistake I see is students that only, well, let's just say they forget some side lengths. Notice that if this is 4, ladies and gents, and this is 3, I suppose that also means this guy is 3. And if the base length is 4, that also means the top length is 4. And in addition, that's a dashed line. That 2 and 5/10 is not even a part of the exterior of that shape. This is a parallelogram, by the way. So if we add 7 and another 7, we're going to get a perimeter of 14, simply talking centimeters. How many centimeters would it take to go all the way around? Now, let's take a walk down memory lane back to probably 6th grade. How do we find the area of a parallelogram? You can't just say length times width because it's not a rectangle. On the other hand, you could cut it up and move that over. And now what is it that we see? We kind of see a rectangle. A rectangle, instead of saying a length, this is a parallelogram, so we'll call that a base length. And instead of saying a width, we'll call that a height. So to find the area of any parallelogram, you must multiply the length of its base times its height. Notice here, we need the 3 for the perimeter, but not the area. The base length is 4 centimeters, and just like at a doctor's office where they ask you, okay, for your height, you need to stand straight up tall, notice where that right angle is. That 2 and 5/10 centimeters is its height. So 4 times 2 is 8, 4 times a half is 2, put those together. 4 times 2 and a half is 10, and centimeters times centimeters is centimeters squared. After all, that's what we wanted to know. How many squares would it take to cover that two-dimensional space? All right, so look at number 1, look at number 2. How are those similar? How are those different? Pause your video, rewind if you need, rewatch. Let's go on to number 5. And again, with number 5, I'm going to ask you to look at number 5, compare it to number 3, and contrast it with number 3. For any perimeter, we're still adding up edges. Big difference, there's only 3 edges here, but a similarity, there's this dashed measurement over here that's not actually a part of that triangle. So let's go ahead and add 7 and 3/10, 5 and 7/10, and 5. If we were to add those together, 5 and 5 makes 10, and 7 is 17, and another whole would be 18 millimeters. Wait a second, Mr. Cowan. We can't say that the area of a triangle is just like its parallelogram. But I want you to look at this. I see a parallelogram in which the triangle that we want is precisely half of the parallelogram that surrounds it. So, ladies and gents, to find the area of any triangle, find the area of the surrounding parallelogram and multiply it by a half. So if you want to see where that formula comes from, you want to listen to that again, go ahead and rewind. But for now, let's go ahead and substitute in the proper dimensions, where the base length is going to be 5 and 7/10 millimeters. And that height, again, we got to look for the right angle here, stand up straight and tall. The height is going to be 3 and 6/10. So I'll go to my trusty calculator. You can use Desmos if you wish. Multiply 1/2 times 5 and 7/10 times 3 and 6/10. Final area of 10 holes, 26 hundredths, and now we're talking square millimeters. So if you look at the green and you compare it, the real big thing I want you to notice is if all you want is a parallelogram, you're going to multiply the base times the height. Now that's going to look kind of familiar as we slide down here. For a triangle's sake, in this case, we want to take the base times the height, but then cut it in half. Because, again, a triangle is precisely half of the parallelogram that surrounds it. That's where that half comes from. So focus on that half a bit. All right, let's carry on, please. Down to number 7, which I think is one of the toughest. Perimeter shouldn't be too bad. 13 is one edge length, and then an 8. I usually just go around clockwise so I don't miss any. 8, and then another 8. Oh, interesting. That 6 is not a part of the exterior of the shape. So if we were to add 8 and 8 and 8 and 13, that's 24 and 13, that's 37 yards around this interesting pair. Oh, it's not a parallelogram anymore. This is a trapezoid. Why is it a trapezoid? Trapezoids have only one pair of parallel sides. You will notice that if we continued on these two side lengths at some point in time, they're going to crisscross. But if you continued one of those pairs, those are parallel, they will never intersect. So parallelograms have two pairs of parallel sides, but trapezoids have only one. To find a trapezoid, we're going to multiply 1/2 times the sum of the two bases times its height. Now, if I could stretch this out just a little bit, for whatever reason, I tend to go with the height first. I don't know why. It just kind of sticks out to me. Stand up straight and tall, right? That's why that 6 is in the picture, because you must have the height. Meanwhile, the two bases are the two sides that are parallel. Whether you write 8 plus 13 or 13 plus 8 won't make any difference. So essentially what we have is 1/2 the product of 21 and 6. And sure, I suppose you could go to your calculator, but listen, 1/2 of 6 is 3, and 3 times 21 will get us a final quantity of 63 square yards. Big deal with that area, ladies and gents. Trapezoids are tough. You see a lot of similarities to the previous one. Instead of just it's not going to let me write on this. That's okay. Instead of a base times a height, it's a sum of two bases times a height. It still has the half. Notice that triangles have a half. Notice that trapezoids have a half, but parallelograms don't need a half, neither do rectangles. All right, so why did Mr. Callan do the odds? Because I would argue if you understand number 1, that you can do number 2 on your own. If you understand number 3, you could do number 4 and on down the line. Ladies and gents, the remainder of your e-learning assignment is going to be completing numbers 2, 4, 6, and 8. If you would like, this is purely optional, you can go to the backside, but we'll talk about that one together in class tomorrow. So there you go. Make sure your math review page is done, 2, 4, 6, and 8. Take care too well. Let's grow. See y'all soon.